Welcome to the distance learning module on climb and departure procedures. In this lesson, we will learn about non-standard climb and departure procedures. Republic contracts aero data to provide obstacle and runway analysis for each airport served. The computer software is used to determine exactly how much payload an aircraft can depart from virtually any airport and still avoid all departure obstacles until 1,500 feet above field elevation. Above 1,500 feet, aerodata does not include performance for ATC restrictions such as crossing altitudes for airspace. When an aircraft is assigned to a departure SID that has no minimum climb chart associated, the pilot will commence the initial turn at 400 feet above field elevation and will accelerate to flap retraction speed at 1,000 feet above field elevation. This is the standard acceleration altitude. When a SID is assigned that contains a published minimum climb chart, aerodata will be responsible to provide the complex special procedure if the climb gradient requirements are restrictive to the aircraft performance. Climb gradient tables were added to the airplane performance manual when it was discovered that pilots needed a method to determine if their aircraft could meet the climb gradient performance outside of what was provided by aerodata. Two separate sets of charts are provided for both the E-170 and E-175 aircraft. VFS and 250 knot climb gradients are obtained using ISA conditions with gear up, flaps up, climb 1, ECS on, anti-ice off, and wings level. Corrections are provided for anti-ice on and climb 2 thrust in the footer of each table. VFS should be used as it will provide better climb gradient performance than 250 knots, as it provides the maximum angle of climb. Let's take a look at the departure out of LaGuardia Airport, which features non-standard acceleration altitudes and non-standard climb gradients. We are cleared the LaGuardia 6 departure, runway 13, Maspeth climb, gale, then as filed, squawking 1234. After 400 feet, we make a climbing right turn to 180, then at the LaGuardia 4.1 DME, a further right turn to heading 340, and maintain 5,000 feet. We must cross the LaGuardia 220 radial at or above 5,000. Looking at the takeoff obstacle notes, we see a minimum climb gradient of 323 feet per nautical mile to 2,100 feet. Next, we see a minimum ATC climb of 900 feet per nautical mile is required to 4,400 feet. That will require the airplane maintaining close to 3,000 feet per minute. ATC wants us to advise prior to taxi if we are unable to comply. Remember that if we accept a clearance, we're obligated to comply. To determine that we can in fact meet this climb gradient, we must reference the airplane performance manual. Today we're flying an E-175 and departing from sea level at 77,000 pounds. ATIS is reporting the temperature of 15 degrees, which is ISA. Since our normal speed schedule is 250 knots below 10,000, let's first examine the 250 knot climb chart. Interpolating the data, we see that we are just above the minimum required climb gradient of 916 feet per nautical mile. Using the VFS chart, we see improved performance of 1,068 feet per nautical mile, which is a much better margin. Taking into consideration that the charts are predicated on wings level, pilot technique, time and distance required to accelerate, and the fact that you must cross the LaGuardia 220 radial at 5,000 feet, maintaining VFS until level off looks like the better choice. Taking a look at the 10.7 page, we see we have a complex special departure with 2 scenarios, all engines operating and engine failure during takeoff. For an all engines takeoff, the acceleration altitude is 1,500 feet, which is higher than standard. Briefing higher than standard acceleration altitudes is a briefing requirement for special considerations during the departure review. For the second time, we see a note to verify climb gradient capability or notify ATC if unable. The actions taken in the event of an engine failure is dependent on where we are when the failure occurs. Below 430 feet, we're going to abandon the turns and simply fly straight ahead. Above 430 feet, we wait until the LaGuardia 4.1 DME and then turn right to 250. If the failure occurs at or after we pass the 4.1 DME, we continue on the SID and request radar vectors. In all three cases, we have a higher than standard acceleration altitude of 1,100 feet.